Hello everyone, this is Sravanthi, working as Assistant Professor of Chemistry in Institute of Aeronautical Engineering. Today I am going to discuss the topic is corrosion. So in this topic, I am going to discuss what is corrosion, what are the types of corrosion, what are the effects of corrosion. So these are the topics today I am going to discuss. So first, what is corrosion? So corrosion means simply we says loss of metal, loss of efficiency of metal. So any process of destruction or deterioration or loss of metal by attacking environment or atmospheric gases on metal surface is called corrosion. So simply we say corrosion means loss of metal by attacking environment or atmospheric gases. Atmospheric gases means such as carbon dioxide, sulfur dioxide, hydrogen sulfide, etc. So, by attacking these gases or environmental conditions like temperature, pressure, etc. on metal surface. So, in this case, when the metal interacts with that environmental gases or atmospheric conditions, so it undergoes corrosion. So, any process of destruction or deterioration or loss of metal by attacking environment or atmospheric gases on metal surface is called corrosion. So, corrosion is a process of reverse of extraction of metal. So here the most common example is rusting of iron. That means iron where it is interacts with atmospheric oxygen. So iron where interacts with atmospheric oxygen then form iron oxide. The best example and common example of corrosion is rusting of iron. So in this case, iron when interacts with atmospheric oxygen, then form iron oxide layer on metal surface. That means reddish color scale formed on metal surface. This is called rusting of iron. So in this case, it lost their valuable properties, durability of that material. So this process is called corrosion and rusting of iron. So during this reddish color scale and powder of oxide, that means rust formula is Fe3O4. Iron oxide is formed and so it becomes, the iron metal it becomes very weak. So this is some of the examples of corrosion, rusting of iron. So in this case, this water pipes where it interacts with atmospheric oxygen, then form reddish color scale on metal surface. So in this case, it becomes weak. So this is the best example of corrosion. So what are the main causes of corrosion? So generally metals are available in nature in the form of metal oxides, metal sulfides, metal carbonates. Generally these metals are available in nature in the form of metal oxides, chlorides, silicates, carbonates and sulfides. But our own need purpose, we extract that metal from these compounds. So metals are available in nature in these compounds. That compounds are called ore or minerals. So when we are using these metals, so we extract the metal from these compounds. So always this natural tendency of metal converts into their original form. This is the main reason metals undergoes corrosion. So here for example, metal generally available in nature in stable form is ore. That means it available in nature as their compounds. That is metal oxides, metal sulfides, metal carbonates, silicates, etc. So that it is called as ore. So it is stable form in nature generally. But our only purpose, we extract the metal from this compound. So for example, iron metal, it is available in nature, iron sulfide, iron oxide, etc. So we extract iron metal from these ore compounds or mineral compounds. So that is pure metal. But it is unstable. So always this metal try to get their original position. That means their mineral compound position. So that is the main reason of corrosion. So therefore, always this metal looks forward their favorable conditions to convert itself back into compound form. That means metal compounds like ore or like metal sulfides, metal oxides, etc. So it occurs in nature, it is minerals. So the natural tendency of metal for conversion into its mineral compound form is called corrosion. So the natural tendency of metal for conversion into its mineral compounds or their original position is called corrosion. But most of the cases when the metal interacts with the environment, that means in the presence of polluted air, water or associated other metal, etc. So what is the meaning of corrosion? The natural tendency of metal for conversion into their mineral compounds is called corrosion. One more definition is loss of metal by attacking environment or atmospheric gases on metal surface is called corrosion. So here the natural tendency of conversion of metal into its mineral compounds from the interaction of environment is known as corrosion. Already just now we discussed. Best example is rusting of iron. So iron metal will interacts with atmospheric oxygen then form iron oxide. It's the best example of corrosion. Already we know that. And one more example is silver. Corrosion of silver by corrosion into its sulfide. Generally silver available in nature, silver compound like silver sulfide. But our only purpose, we extract the silver metal from the mineral compound. So this process called tranching. The loss of silver metal, this process called tranching of silver metal. This is one more example of corrosion. So what are the effects of corrosion? Here, loss of useful properties of metal. Loss of useful properties of metal. What are the properties, valuable properties of metal such as malleability, ducticity and electrical conductivity, and most important thing is loss of efficiency of metal. Loss of efficiency of metal and also decrease in production rate. So because efficiency is less and the replacement of corroded equipment is time consuming. And one more thing is increase in maintenance and production cost. Generally, if that metal undergoes corrosion means increase the maintenance also required. We applied some lubricants. So production cost also increases. And contamination of product. The loss of efficiency of metal. This is the main effects of corrosion. So now discuss what are theories of corrosion. Generally, there are two theories, two types of corrosion there. One is direct chemical corrosion or dry corrosion. Dry corrosion or direct chemical corrosion. Wet corrosion or electrochemical corrosion. So there are two types of corrosion is there. Dry corrosion or direct chemical corrosion. Wet corrosion or electrochemical corrosion. So first we discuss dry corrosion. What is the meaning of dry corrosion or direct chemical corrosion? So direct chemical action of environment or atmospheric gases. Atmospheric gases means such as oxygen, halogen, hydrogen sulfide, sulfur dioxide, nitrogen or anhydrous inorganic liquid without the metal surface. So this type of corrosion occurs mainly direct chemical action of environment. Environment factors means like pollution, air, temperature, humidity. So many environmental factors are also affecting on metal surface and also affecting the atmospheric gases such as oxygen, halogen, hydrogen sulfide, sulfur dioxide, nitrogen, etc. So on the metal surface. So in this case, metal undergoes corrosion when it interacts with these gases. So there are three types of chemical corrosion. So one is oxidation corrosion, corrosion by gases, corrosion by liquids or liquid metal corrosion. So there are three types of chemical corrosion. So now we'll discuss what is meaning of oxidation corrosion. Oxidation corrosion means direct chemical action of oxygen. Oxidation corrosion. So direct chemical action of oxygen on metal surface at low or high temperature. Temperature range is important here. So oxidation corrosion means direct chemical action of oxygen on metal surface at high or low temperature and usually in absence of moisture. Usually in absence of moisture is called oxidation corrosion. Dry corrosion means direct chemical action of environment or atmospheric gases on metal surface. But what is the meaning of oxidation corrosion? Here, metal interacts with atmospheric oxygen at low or high temperature, usually in absence of moisture, is called oxidation corrosion. So which metals are oxidized at high temperature, low temperature or normal temperatures? So generally alkali and alkali earth metals. Alkali means first A group elements. So such as lithium, sodium, potassium, rubidium, etc. And alkaline earth metals, calcium, magnesium, like second A group elements. So alkali and alkali earth metals are rapidly oxidized at low temperature only. So these metals are oxidized at low temperature. But high temperature, almost all metals are oxidized except noble metals such as silver, iron, platinum. Why these noble metals are not oxidized or doesn't undergo corrosion mostly? Because these metals are having high corrosion resistance. So that's why this metal doesn't undergo corrosion. That means these are having high corrosion resistance. So now let's discuss what is the meaning of oxidation corrosion. Direct chemical action of oxygen on metal surface. So when the metal interacts with atmospheric oxygen, then it forms metal oxide layer on metal surface. So this type of corrosion occurs generally at high or low temperature, usually in absence of moisture. That's why it is called dry corrosion and this oxidation corrosion. So generally in this oxidation corrosion, alkaline and alkaline earth metals. Alkaline means first A group elements such as lithium, sodium, potassium, rubidium, etc. So these metals and alkaline earth metals. These metals also, alkaline earth metals means second A group elements like calcium, magnesium, like that. So these metals are oxidized only at low temperatures. So at high temperature, almost all metals except noble metals, because noble metals are having high corrosion resistance. So these metals are oxidized only at high temperature. That means at high temperature, almost all metals are oxidized except noble metals. So what are the reactions takes place? So the metal, any metal where it is undergoes oxidation. So already we know that oxidation means here loss of electrons. So in any metal, if in case it undergoes oxidation, so in this case it gives metal ions. It gives metal ions and loss of 2 electrons because it is a oxidation reaction. So any metal it undergoes oxidation then gives metal ions and loss of 2 electrons. So at cathodic area, that means reduction process. So in this reduction, oxidation is involved. So oxygen gain of electrons, because reduction means gain of electrons. So oxygen and gain of electrons then gives 2O2 minus. So what is the overall net reaction in this oxidation corrosion? So when the metal interacts with atmospheric oxygen, then form metal oxide layer on metal surface. So this metal oxide layer plays an important role in this oxidation corrosion. For example, here metal. So this metal when interacts with atmospheric oxygen. So this metal, any metal, when it is interacts with atmospheric oxygen, then form metal oxide layer. So this is metal oxide layer. When the metal interacts with atmospheric oxygen, then form metal oxide layer formed on metal surface. So what is the mechanism involved in this? So when the metal interacts with atmospheric oxygen, metal diffuses outward direction. So metal diffuses outward direction and oxygen diffuses inward direction. So both the transfer occurs. Finally, it forms metal oxide layer formed on metal surface. This is the main mechanism involved in this oxidation corrosion. So any metal when interacts with atmospheric oxygen then form metal oxide layer. So in this case, metal diffuses outward direction and oxygen diffuses inward direction. So both transfer occurs. Finally, it forms metal oxide layer on metal surface. So this metal oxide layer plays an important role in this oxidation corrosion. So that means here, for example, this metal undergoes oxidation. It diffuses outward direction. So in this case, metal undergoes oxidation then gives metal ions and loss of electrons. So oxygen diffuses inward direction. So in this case, oxygen, gain of 2 electrons, then form O2. So finally these both diffusions takes place, finally it forms metal oxide layer on metal surface. So here this metal oxide layer plays an important role in this oxidation corrosion. That means sometimes it acts as protective, sometimes it acts as non-protective. So which cases it is protective, which cases it is not protective, discuss now. So if the metal oxide layer is stable, that means for example, this is a metal, any metal, when it is interacts with atmospheric oxygen, because it is a oxidation corrosion. So generally metal interacts with atmospheric oxygen. So when the metal interacts with atmospheric oxygen, then form metal oxide layer on metal surface. This is a metal oxide layer formed on metal surface. So when the metal interacts with atmospheric oxygen, then form metal oxide layer on metal surface. So it is stable. So in this case, it is stable means it protects the base metal. It protects the metal surface. So in this case, does not undergo corrosion. So that is the main thing. If the metal oxide layer is stable, that metal oxide layer behaves as protective layer. So it prevents further corrosion. It prevents from corrosion. So which metals are formed the stable metal oxide layer? The oxide films of aluminium, tin, lead, copper, chromium. So these metals mainly form stable metal oxide layer. For example, aluminium, where it is interacts with atmospheric oxygen, then form aluminium oxide. So it forms stable metal oxide layer. So that means it doesn't undergo corrosion. That means it protects the metal from corrosion. So these aluminium, tin, lead, copper, chromium. So these metals are form stable metal oxide layer. So that means it protects from corrosion. So if the metal oxide layer is unstable, so that means, for example, same thing. Here, this is a metal where it is interacts with atmospheric oxygen, then form metal oxide layer. But it is unstable. So in this case, it is decomposed back into metal plus oxygen. So here, fresh metal surface is available. Okay. So if the metal oxide layer is unstable, so in this case, if the metal oxide layer is decomposed back into metal and oxygen. So in this case, generally it is non-protective, but best example is here silver, iron, platinum. If in case these metals form this type of layer, means it is protective only, because these metals are having high corrosion resistance. These metals are having high corrosion resistance. So in this case, this metal oxide layer forms an unstable layer, but it is protective because these are having high corrosion resistance. But not this noble metals, any other metal you are taking here. So in this case, it forms unstable metal oxide layer. That case, it is non-protective. But if we are using noble metals, in this case, that metal oxide layer acts as protective. In this case, if in case we are using noble metals, in this case, this metal oxide layer acts as protective. If in case we are using other than noble metals, in this case, that metal oxide layer acts as non-protective. Now let's discuss if the metal oxide layer is volatile. Volatile means sudden changes occurs on metal oxide layer, or metal oxide layer is evaporate. So in this case also, fresh surface is available. For example, here, best example is molybdenum oxide. For example, this is a metal, molybdenum metal, where it is interacts with atmospheric oxygen, then form molybdenum oxide layer is formed, but it is volatile. That means it is evaporate or sudden changes occurs on this metal oxide layer. So in this case, any other chemicals attacking on metal surface. Any other chemicals attacking on metal surface. So if the metal, for example, in this, if the metal oxide layer is volatile, in this case we are taking molybdenum oxide. So when this molybdenum metal interacts with atmospheric oxygen, in this case it forms molybdenum oxide layer, but it is volatile. That means sudden changes occurs on metal oxide layer, or otherwise this layer is any reason it is evaporates. So in this case fresh metal surface is available. So fresh metal surface is available means any other chemicals or atmospheric gases attacking on this metal surface. So in this case also metal oxide layer acts as non-protective. Non-protective. If the metal oxide layer is stable means protective. If the metal oxide layer is unstable means if in case we are using noble metals, protective. Other than noble metals, non-protective. If the metal oxide layer is volatile, in this case also this metal oxide layer acts as non-protective. Now discuss. If the metal oxide layer is porous, that means simply we say it is non-protective, because if the metal oxide layer getting pores, so in this case through these pores any other chemicals attacking on metal surface, so that's why this metal easily undergoes corrosion. So any pores are formed on metal surface, in this case also metal oxide layer acts as non-protective. Best example is alkali and alkali earth metals, first A and second A group elements such as lithium, sodium, potassium, calcium, magnesium, etc. So these metals when interacts with atmospheric oxygen then form porous metal oxide layer. So that's why these metals easily undergoes corrosion, because that metal oxide layer acts as non-protective in nature. So one more rule also tells that metal oxide layer protective or not. So that is clearly explained by this Pilling-Bedworth rule. So according to Pilling-Bedworth rule, the volume of oxide is greater than volume of metal. So the volume of oxide is greater than volume of metal. In this case, that metal oxide layer acts as protective or non-porous. If the volume of oxide is less than volume of metal, in this case, the metal oxide layer is non-protective or porous. So, for example, to simply this is according to Pilling-Bedworth rule, the volume of oxide is greater than volume of metal. In this case, it is protective. For example, aluminium oxide. Okay, here aluminium, when it is reacts with atmospheric oxygen, then form aluminium oxides. So in this case, it acts as protective. Why? It is clearly explained by Pilling-Bedworth rule. That means the volume of oxide in this aluminium oxide, the volume of oxide is greater than volume of metal, that means aluminium. So that's why this metal oxide layer acts as protective according to Pilling-Bedworth rule. For example, the volume of oxide is less than volume of metal. So in this case, non-protective. So for example, alkali and alkali earth metals, this metal oxide layer is non-protective. How can we know that? So it is clearly explained by Pilling-Bedworth rule, because the alkali and alkali earth metals oxide layers, the oxide volume is less than volume of metal. So that's why that metals, alkali and alkali earth metals form non-protective layer. That metal oxide layer is non-protective. So formula is PB ratio, Pilling-Bedworth ratio is equal volume of metal oxide by volume of metal consumed. Volume of metal oxide by volume of metal consumed. So this PB ratio is slightly greater than 1. So in this case, the metal oxide layer will be protective. So in this ratio, PB ratio, how can we calculate PB ratio? The volume of metal oxide by volume of metal consumed. So if the PB ratio is slightly greater than 1, so in this case, the metal oxide layer will be protective. So other than it is non-protective according to Pilling-Bedworth rule. Now second one in this dry corrosion is corrosion due to the other gases. So just to discuss already, dry corrosion means direct chemical action of environment conditions or atmospheric gases. So based on this, this dry corrosion classified into 3 types: oxidation corrosion, corrosion by gases, corrosion by liquids. So oxidation corrosion means generally metal interacts with atmospheric oxygen, then form metal oxide layer on metal surface. It is called oxidation corrosion. Now let's discuss metal interacts with atmospheric gases or any other gases. So in this case, this type of corrosion mainly due to gases like sulfur dioxide, carbon dioxide, chlorides, hydrogen sulfide, fluoride, etc. So when the metal interacts with atmospheric oxygen, then in this case, corrosion product is formed on metal surface. That means metal undergoes corrosion when it interacts with this atmospheric gases. So here, the degree of attack depends on the formation of protective or non-protective films on the metal surface. So which is explained the basis of Pilling-Bedworth rule. So Pilling-Bedworth rule, just now we discussed, it is explained which metal oxide layer is protective, which metal oxide layer is non-protective. For example, in oxidation corrosion, the volume of oxide is greater than volume of metal. So in this case, it is protective. But the volume of oxide is less than volume of metal. In this case, non-protective. So same concept here also we can applicable. So according to Pilling-Bedworth rule, when the metal interacts with atmospheric gases such as sulfur dioxide, carbon dioxide, chlorides, sulfur, hydrogen sulfide, fluorides, etc. So in this case, it forms corrosion product. So the corrosion effect depends mainly on the chemical affinity between the metal and the gases is involved. So this layer is protective or non-protective clearly explained by Pilling-Bedworth rule. So for example, if the volume of corrosion film, here gaseous film, so the volume of corrosion film formed is more than the underlying metal. It is strongly adherent. That in this case, it is non-porous. In oxidation corrosion, the volume of oxide is greater than volume of metal, protective. In the same way here also, the volume of corrosion film formed is more than the underlying metal. So in this case, it is non-porous and does not allow the penetration of corrosive gases. So it protects the metal from corrosion. Best example is silver chloride. So silver, where it interacts with atmospheric gases. For example, here we are taking chloride. So when the silver interacts with chlorine, then form silver chloride. So this metal oxide layer acts as protective. For example, if the volume of corrosion film, that means corrosion, a gaseous layer formed on metal oxide, formed on metal surface. So in this case, the corrosion film formed is less than the underlying metal. So in this case, that means it forms pores or cracks and allow the penetration of corrosive gases. It leads to the corrosion of the underlying metal. If any pores are formed on the gaseous layer or corrosion film, so easily it attacks any other corrosive products. That means chemicals. So that metal easily undergoes corrosion. So the best example is tin chloride. When tin interacts with chloride, then form tin chloride gaseous layer. But this corrosion film, it is less than the underlying metal. So that's why it forms pores or cracks on this gaseous film. So in this case, that metal oxide layer acts as non-protective according to Pilling-Bedworth rule. Now discuss liquid metal corrosion. So simply is a liquid metal corrosion. The metal interacts with liquids. The metal partially or completely dipped in liquids like water or aqueous electrolytes or metal contact with conducting liquid. So in this case, this type of corrosion occurs. So generally this type of corrosion mainly observed in nuclear reactors. So liquid metal corrosion or corrosion by liquids. So this corrosion mainly due to the chemical action of flowing liquids metals at high temperature on solid metal or alloys. So such corrosion has been found occur in devices which are used in nuclear reactors. So this type of corrosion mainly due to the chemical action of flowing liquid when the metal interacts with liquids at high temperature. So on solid metal or alloys generally observed in nuclear reactors. Such corrosion has been found to occur in some devices which are used for nuclear reactors. So this corrosion involves the dissolution of solid metal by flowing liquid metal or flowing liquids. and internal penetration of the liquid metal into the solid metal. And when we are applying some liquid lubricants, release quality of lubricants. In this case also this type of corrosion arises. And both the modes of corrosion, in any case, it becomes weak in the solid metal in nuclear reactors. Weak in the solid metals in nuclear reactors. So simply we say when the metal interacts with the liquids, in this case this type of corrosion occurs. Mainly this type of corrosion we observe some devices which are used in nuclear reactors. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.